Now we're going to look at exponential equations that can be written to a common base. We actually have two types of exponential equations, those that have bases that can be written as powers of a common base and those that can't. Now this video is only about those that do have a common base. Now here's my steps. Isolate base to unknown power. Rewrite both sides to the same base. Now in order for the equations to be true, the exponents must be equal. And therefore what we're going to do is sort of pull out the exponents and set them equal to one another. And always check. If you have yourself an equation, you can always check them. Now in this one, notice I've got 5. Usually I look at my smaller base and see if I can rewrite the other side to that base. So I can rewrite 25 as 5 squared. Well, for this to be true, guys, this exponent has to equal that exponent. So I'm going to pull those out and set them equal to one another. And now I'm back to a very simple equation. I'm going to subtract 1 and then divide by 2. So my x here should be 1/2. Well, let's see. I'm going to store 1 divide by 2, storing for x, and then type in the side that has your variable. 5 raised to, I need parentheses here, 2x plus 1. And if I come up with 25, I've got the right answer, so I put a little tiny baby check mark. Now this one, 16 is my smaller base. I cannot rewrite 32 as base 16. What about 4? 16 is the same thing as 4 squared, but I can't rewrite 32 as 4 raised to a power. So what about 2? 2 to the 4th gives me 16, and 2 to the 5th gives me 32. Now check out how I rewrote this. First you have to rewrite it. Now if those particular bases that you're trying to rewrite are also followed by a power, you need to put them in parentheses, because remember my exponent rule that deals with a base raised to a power and that in turn raised to a power. I've got to multiply these. So the left hand side becomes 2 to the 5x, and the right hand side becomes 2 to the 4 minus 4x. Now my bases are the same. Pull out my bases, set them equal to one another. So I'm going to add 4x. That'll give me 9x equals 4, or x equals 4 9ths. So let's try this one. 4 divided by 9, storing for x. I've got to type in both sides. 32 raised to the x gives me that number. 16 raised to, I need parentheses, 1 minus x. If it gives me the same thing, I've got it right. So that's my correct answer. This one's a little bit different. Now I need my base where it's in the numerator. So if I do that, this would be 2 to the negative 1, and I can rewrite this side as 2 squared. So if you have a fraction, you're going to end up with a negative exponent. I need to multiply these, so that would be 2 to the negative x. Bases are the same. Set my exponents equal. Now I don't want negative x, I want x. So x should be a negative 2. So let me store negative 2 in. Parentheses 1 divide by 2. Raise it to the x power, and let's see if I end up with 4. So that one checks. So I've got a few more. So you might pause me and try these on your own. 3, I can't rewrite 3, so the 27 has to be able to be rewritten as 3. So 3 to the 3rd. Bases are same. Set exponents equal to one another. Divide by 7, so my x should be 3/7. So you might store that and try it. You'll need parentheses around that exponent when you check. 4 is my smallest number here, can I rewrite this side? That would be 4 squared, but I don't want 4 squared in the bottom. I got to have it up, so that would be 4 to the negative 2. Let me move it up. Set exponents equal to one another, and that one's already done. So x to the negative 2. Let's try this one. Negative 2, storing for x, 4 raised to the x. That gives me that. Let's go frac it. There's my 1/16. This one, well, we already played with 4 here. This will be 4 squared. Set your exponents equal to one another and solve. I'm going to add 5, divide by 3, and your x would be equal to 7/3. So I'm going to leave this for you to check. Thank you. That's it.